Okay, welcome back, AP Chem students. This video is going to be on dilutions, and this is a new concept for us. We've not done this in regular chemistry, but it's a necessary concept to learn for our lab kit that's coming up on Monday. And if you have taken a look at the pre-lab, you'll notice that question 5 asks you to do a set of dilutions. And a few of you have asked me, well, how do I do a dilution? And that's what this video is all about. So what is a dilution? Basically, we dilute things in chemistry to decrease the molarity of whatever that solution is. This is necessary when things are too concentrated. And it's done by simply adding distilled water to the solution. And I'd like you to recall that molarity is equal to moles per liter. All right, moles per liter. So here's a little drawing, an example of what a dilution might incur. Right here, I have a 12 molar stock solution. Stock means the solution that we keep in storage. And you can see that at a very low volume and that the particles or the moles of solute are very, very close together. Not too surprising for a very concentrated solution. And let's say I added some distilled water, and now the new molarity is 6 molar. Well, you can see that the volume has risen in the new dilute solution, as it should, because I added distilled water, and the moles or the particles of stuff dissolved in the solution are a little bit more spread out. This is the more dilute solution or watered down than it was before. So how do we actually calculate dilutions in chemistry? It's actually a very simple formula. It's M1V1 is equal to M2V2, or the molarity of your stock solution multiplied by the volume of your stock solution needed is equal to the molarity of the dilute solution that you want to make times the volume of the dilute solution that you want to make. Okay, here's an example problem below of what a dilution would incur. Let me get rid of this extra thing right here that we don't need. How would I prepare a 6 milliliter of 10 molar sample of sodium chloride solution using a 20 molar stock solution? Okay. So what the question is asking you to do is, how do I prepare 6 milliliters of a 10 molar solution, that's NaCl, if I've got a solution in stock of 20 molar? Well, we know that M1V1 is equal to M2V2. And I like to write down all of my givens. Alrighty. M1 is the molarity of our stock solution. Well, in the problem it says the molarity of our stock solution is 20 molar. And I'm going to break down molar down to moles per liter. Okay. The volume of stock solution that we want to make is 6 milliliters. That's our V2. The question is asking, how do I prepare 6 milliliters of a 10 molar solution? So I need to make 6 milliliters, which means V2 is 6 milliliters, since V2 is volume of dilute solution you want to make. So V2 is equal to 6 milliliters. All right. It's telling me to make a 10 molar solution. That's what I want to make. M2 is the molarity of dilute solution that I want to make. So M2 is equal to 10 moles per liter, which means V1 is what I'm looking for. It didn't specify how much of the stock solution I need. I need to figure that out, okay? Moles per liter is molarity, which means if we're dealing with when we have volume, we need to make sure that all of our volumes are in liters as well. So I've got to convert this 6 milliliters into liters. And you should be pretty familiar with unit conversions by now. So it's going to be 0.006 liters that I'm trying to make. I'm looking for V1, so all I need to do is rearrange this equation such that V1 is by itself, and I'm just going to divide by M1 on both sides, which means V1 is equal to M2 V2 over M1. And now I can plug in. M2 is equal to 10 moles per liter. V2 is equal to 0.006 liters. And M1 is 20 moles per liter. All right. These are going to cross cancel, which means I'm left with liters, which makes sense because volume is what I'm looking for. I'm sorry, let me pull this up here. And now all I need to do is plug it into my calculator. Let me pull my calculator up right here. I'm going to do 10 times 0.006 divided by 20. That means I'm going to need 0.003 liters of the stock solution, okay? I'm going to need 0.003 liters of the stock solution, or 3 milliliters of the stock solution. Okay, so how do I prepare my final dilution? Well, I know I need 3 milliliters of 20 molar stock. And it says I need to make a total of 6 mils. All right. So to that 3 milliliters of stock solution, I'm going to add 3 milliliters of distilled H2O, and then that's how I would make that solution. Let's go ahead and relate this topic to what you had to do on question 5 of your pre-lab. The concentration of the stock solution that we're going to use is rather small. It's 7 times 10 to the negative 6 moles per liter. In actual chemistry, we will deal with concentrations that are very, very low like this. That is not uncommon. What the problem is asking you to do now is to calculate the concentration of each solution based on the dilution information it gave for you right here. So for the first one, it's telling you to take 10 milliliters of the stock solution at this concentration, add 0 milliliters of distilled water. What would the new concentration be? Well, that's actually very easy. It's just going to be the same concentration of the stock solution. Okay, because we didn't add anything new to it. For absorbance, don't worry about this. We're going to do that on the day of the lab. Now, let's do the concentration for when it tells you to take 9 milliliters of stock solution and then add 1 milliliter of distilled water to it. That's a dilution problem. Let's go ahead and try it out. Okay. We know that M1 V1 is equal to M2 V2. For the problem, the stock solution is at 7.0 times 10 to the negative 6 moles per liter. So my M1 is equal to 7 times 10 to the negative 6 moles per liter. My V1, which is the amount of stock solution I need, was given to me as 9 milliliters, or 0.009 liters when you convert it to liters, which you have to do. My V2 is the total volume of the solution that I'm trying to make. Well, the total volume of the solution is 9 milliliters of stock plus 1 milliliter of distilled water, so that's a total of 10 milliliters. But we got to convert that to liters, which is going to be 0.010 liters. 1, 2, 3, yeah. 0.010 liters. My M2, that's what I'm looking for in this case, because that's this concentration right here. After I add 9 milliliters of stock to 1 milliliter of solution, what's my new concentration going to be? Let's figure it out. Rearranging this equation to solve for M2, M2 is going to equal to M1 times V1 over V2. We know that M1 is equal to 7.0 times 10 to the negative 6 moles per liter. V1 is equal to 0.009 liters. And that's going to be over V2, which is 0.010 liters. These liters cross cancel. At the end, our units will be moles over liters, which is molarity. And now you just need to plug this into your calculator. And this is where having a scientific calculator will be very helpful, because we're dealing with things in scientific notation. So I have 7.0 times 10 to the negative 6th power times 0.009, then divided by 0.010. My new molarity, I'm going to write it over here, is equal to 0.000063 moles per liter. Make sure I counted those zeros correctly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Now you can rewrite this in scientific notation, which you should. That's just moving this decimal place over. 1, 2, 3, 4, 5, 6 will give us the first digit between 0 and 10 times 10 to the negative, how many did I count again? I forgot. 1, 2, 3, 4, 5, 6. Negative 6 power moles per liter. And that's what you'll write right here. Okay. Sorry, I got a little sloppy there. All right, and that's basically all it is to it. You're going to continue to do the same thing for each one of these problems here, except this time you're using 8 milliliters of stock solution and 2 milliliters of stock solution. And all you got to do is plug it into the formula. Just like we did it right here, you're solving from M2 each time. We'll see you on Monday. Feel free to get a hold of me on theremind.com or on the Google Classroom if you have any questions.